It's 3 a.m. in a big payments company, and PagerDuty alerts us that database is at 95% of its capacity for 39 seconds. Payment transactions have been failing worldwide due to this big error, and $18,000 have been lost in the revenue. Now, whose job is to handle this is an on-call engineer who has 45 minutes of investigation ahead of him to find what's causing all of this. Or does he? Let's look at something very interesting to help him solve all of this in no time. So what you can see over here is an IncidentIQ project for this hackathon of ours, organized by We Make Devs and sponsored by Archestra, which is a core part of what we are using right now. So here's what our outputs looks like at the end of the day. Sorry, not at the end of the day, at the end of the processing. So it has been saying like correlation status found, confidence is high, and here's what it shows the timelines. So the root cause is a cost saving downgrade has been made earlier from this instance to this instance, and a human who would have looked at for like 45 minutes for checking the code, all of the dependencies, metrics, and everything, our agent has already took a very less time in order to solve all of this. So as you can see, it has given everything, and at the end, it provides us with the evidence like CloudTrail. Sorry, the recording have been messed up a little bit, so I'm starting again. So you have been seeing like a couple of evidences over here. One of them says that insufficient RAM for hash join, that is due to the instance change from DB micro to that has been changed to DB micro from the medium one. We'll see that on the actual logs on AWS. And a Slack message that reflect that need to cut down some of our resources, maybe dropped a message by the manager of DevOps and infra over the company. And the GitHub commit says none of the code has been changed. So definitely it has to do something with the instance changed. So let's have a look at it on the CloudTrail, CloudTrail actually. So that lists up the uh, evidence for us that have happened actually at the time of the crash. So if you look at it, it says that the instance have been modified from actually the T4G medium to T4G micro. That has been, which is a huge jump. Next, if you look at it, the logs. So initially it used to take almost 21 seconds to complete all of this. But actually, after the drop of the DB instance, it takes almost 39 seconds, which is a huge jump for a big organization that has been handling very severe payments. And what behind the scenes does this is our Python function, uh, which actually calculates the duplicate billing have happened potentially during throughout the day. So one time that it runs is in the morning and in the evening. So yeah, that's how it goes over here. Also, if we have a look at it on our Slack channel, which has been, a dummy where I have pasted this log so that it can help us to bring this demo to you. Because, I can't make all of those channels and bring so many people to drop some dummy messages for me. So yeah, that's how it looks over here. So next is like, how does Orchestra has helped us in setting up all of this? So Orchestra is a big part, which is managing all of our agents behind the scenes. So each of our agent has a dedicated LLM defined. In our case, we are using GPT-5 for a very good intelligence, and we have defined a couple of system prompts over here. In the rest of the agents, we have been using GPT-5 mini to provide us the information from the other MCP servers because it costs us less. I have spent a lot of money